Hello, everyone. In chapter 4, we talked about uh, probabilities. We introduced the concept of probabilities, and we introduced the idea of having different types of probability assessments, like relative probability assessment, or classical assessment, or subjective assessment. And we found probabilities for a single event or a group of events. The idea is to learn how to find the probabilities and understand the idea of how the chance of the events, what is the chance of events occurring. So this was the idea of chapter 4. Chapter 5, we started talking about not just one event. No, we need to study one variable. We need to study not just one little thing. We need to study a variable, a random variable, and we need to study all values that random variable takes and the probability for each of these values. Not only this, we need to see the picture. We need to see the distribution of this, the distribution. So we need to see the table, the probability distribution, or we need to see the histogram or the graph to understand what's going to happen in the future, the chance, because we need to make, okay, at the end, we need to make decisions about the future, right? So we need to study the probabilities and the chance of the events occurring. So we focused on one random variable because this is, at the end of the day, is going to be your business. When you solve a problem, any business problem, at the end of the day, you have a focus. You'll focus on one problem. You'll focus on one variable. Then you're going to study that variable. What is the chance that this variable is going to occur? You will be study all of the learning sample space, all of the possible outcomes of that variable. You will not study only one possible outcome. No, you will be studying all of the possible outcomes for that variable. So you have a full understanding of the business problem. So we introduced the probability distributions in chapter 5, and we talked specifically about discrete probability distribution, right? And we chose one type of these. We chose the what? We chose the binomial probability distribution, right? It's an example of the probability distributions because we have so many examples. So the one that we chose was the binomial probability distribution. And the probability or the binomial distribution has many characteristics and checklist, as we said, we have to check before we decide whether, oh, this one belongs to binomial or no. Can we use binomial distribution or no? And we had examples using Excel as well. Now, in chapter 6, it's clear that the first word you see is not discrete, it's continuous. And we made connections between the discrete and continuous with what? With the random variable. So when we say continuous probability distribution, that means we're talking about the random variable here. The variable of interest. The variable that we are looking for to know the probabilities for each possible outcome. So the random variable in this case is going to be continuous. That's why we are going to have continuous probability distribution or distributions. We have many of them. We will be focusing on two distributions. The first one is going to be, which is a very common, famous, important distribution, which is the normal. And out of the normal, we're going to learn something about standard normal. We're going to standardize it. So the normal distribution, and we will take that normal to standardized format, so it's going to be named standard normal distribution. And the second one is going to be the uniform, which is short and doesn't have that much. It's simple compared to the normal. So, yeah, so this is what we are going to do. Examples. Suppose a pharma company may be interested in the probability that a new drug will reduce the blood pressure. So our main interest is the blood pressure. This is my variable. This is my random variable, RV, random variable, not the car, RV. So it's my random variable. This is going to be continuous random CRV. So this is the continuous random variable. Or the cereal company, they care about the probability that the cereal boxes labeled as containing 16 ounces will actually contain at least that much cereal. This is common, by the way. They say 16, then when you weigh it, you get 14 something. So 16 ounces. So this is the weight, right? So this is the continuous random variable, CRV, that we are going to study. These are examples. So these are some of the variables that we care about. We need to study, right? Another example, Pepsi can is supposed to contain 12 ounces, but it might actually contain any amount between 11.9 and 12.10 ounces, such as 11.98 ounces. So when the variable of interest, such as the volume soda in a can, is approximately continuous, so the probability is continuous, and we call it continuous probability distribution, as we said. Okay? One important difference between the discrete and the continuous probability distributions involving what? The calculations of the probability. Calculations. Probability. Especially when we do the calculations of probabilities associated with the specific values of the random variable. For example, suppose that in a market research example, we have 100 people are surveyed, and they were asked whether they have a positive view of a product or no. So the question was, do you have a positive view or no? So n is 100. We surveyed 100. We asked them, if you remember, whether they have a positive view or no. Positive view about the product or no. So we have only two outcomes. So in this case, the random variable is discrete values, right? And is going to take values. If we care about this variable, the people who have positive views, it varies. It's going to be between 0 and 100, right? If we choose our variable to be people who have a positive view, then the random variable is going to take values between 0 to 100. Then if I ask you, what is the probability of x equals to 20? So you can tell me that. We can use basically here binomial distribution, because it's a discrete and we have two outcomes, etc. All of the conditions met. But the idea here is you can ask me specific requests. You can ask me specific number of positive views. You can tell me if I assume that this is my random variable. P of x equals 20. You can ask me P of x equals 50. What is the probability that x equals 50, or number of people who have a positive view is 50? What is the chance that people who have a positive view about the product is 20, and so on, right? We can ask a specific question. However, in the Pepsi example, if I ask you what is the probability that a Pepsi can contains this amount, what is going to be the answer? What is the probability that a Pepsi can contains 11.95 ounces? That is going to be 0, simply. There's no chance that we'll find a can that contains that very specific number, because we're talking about continuous variable, because we have uncountable infinite numbers of possible outcomes of that random variable. So you'll never have this exact number. 11.95. So when you have a continuous probability distribution, you cannot ask me what is the probability that x is equal to a number. You can do this when you have a discrete probability distribution, but when you have a continuous probability distribution, you cannot do this. However, you can use the range of values. For example, you can tell me what is the probability of x the can contains less than or equal 11.95. Oh, that's okay. So even the equal, this is exactly, if you write this probability like this, it's going to be correct as well, because we don't have equal. So these are the same, okay? These are the same, basically. So you can use the range. When you have a continuous probability distribution, my idea is you cannot say exact, you cannot find the exact probability for a certain variable, for a certain value. However, you can do this for a range. So for the Pepsi, you can ask me, what is the probability that the can contains less than 11.5 ounces? Or you can tell me what is the probability that the can contains greater than 12 ounces, 12.1 ounces. Or you can tell me what is the probability of x between two values, x between, let's say, 11.8, not 1, and 12.2, let's say. So you can use the ranges in the continuous probability distribution, and this is an important idea when we talk about continuous probability distribution. We don't have exact value. You can't, again, let me repeat, you can't say what is the probability of x equal. X cannot be the random. This is the random variable, cannot be equal a specific value, because we don't have such values. Okay, so most probably the probability is going to be 0. So the first type of the probability distribution is what is so-called the normal probability distribution. Is a normal probability distribution, which is the bell-shaped symmetric one, which is the one that we always see. This bell-shaped curve and distribution means what? Again, if someone's going to ask me, what are these now, guys? These are probability distributions, the one that we did in chapter 5. Watch the video when we make a comments between the frequency distribution and the probability distribution. This is actually comes from like histograms, like bars, something like this. And we ended up having this guy, curve. And yes, here we have the y-axis, here we have the x-axis. So don't get confused. Oh, something new. No, here we have x, the random variable. Here we have the probabilities. as we did in chapter 5. Watch that video that I'm talking about. But now we have continuous probability distribution. So it's going to be, we have to be careful when dealing with this now, because we don't have it's hard to find a specific probability. Yeah, someone's going to say, okay, the y-axis is the probability of x equals x, correct? So this has a complicated formula to be found. So we will not find the probability for a certain value. So we will not do this. We'll not look at this number and find the probability from here. No, this is continuous. We need to look at the range, basically. So we'll be talking about that one. So the normal distribution has some properties. First of all, is a unimodal, single peak value, which is that one, right? It's symmetric. Symmetric means what? Now we speak about the area. It's interesting to start speaking about the area under the curve. The area under the curve is 100%. And because it's symmetric, we know that the mean is in the middle, right? We know that it's symmetric. So the mean, because it's symmetric, the mean is in the middle. So the area on the right-hand side of the mean is going to be 50%. Okay, it's half. The other one is half. The area under the curve. Why we care about the area under the curve? This is important. Why we start talking about the area under the curve? We did not speak about this earlier. Yes, because the area under the curve is going to be the probabilities that we are going to find. It's going to be the probability associated with a certain random variable within a range. We know that when you have a symmetric or bell-shaped distribution, that means mean, median, mode are equal, right? Both sides, the curve doesn't touch the x-axis. It goes to infinity, basically. So it doesn't touch the x-axis. The last point is what? The amount of variation in the random variable determines the height and the spreadness of the normal distribution. The spreading when we talk about the standard deviation. If your data is really spread, it has high spread, it's going to be something like this. Look at the standard deviation, super high compared to that one. Standard deviation tells you that your data is distracted about the mean, is away from the mean. When the standard deviation is low, then the data is scattered around the mean. Your data is scattered around the mean. Okay? So that's why the variation, we're talking about standard deviation here. The standard deviation of the random variable tells you the height and the spread of the normal distribution. Okay, this is a very important statement. The area under the curve corresponds to the probability. Why? Because x is continuous random variable. The probability p of x is equal to 0 for any particular x. That's why, as we said before, we can find the probability for a range of values between x1 and x2 by finding the area under the curve between these two values. I will not explain this. This is we call it the probability density function, but the idea is we'll be talking about the probability which equivalent to the area under the curve. Let me have an example. Well, let me do an example in the next video.